Right, first week of differentiation. We'll try to go through the basics this week. Do we know the formula for differentiation from first principles? Any idea? The f of x plus h, the f of x, all over h, exactly. So, if this is your function of x is equal to x squared plus 6, how will I get the function of x plus h? What's that? So it's a bit like the functions we did last week. That's why we go from functions into this. There's the function of x. This time it's x plus h in the bracket. So instead of having x squared plus 6, it's x plus h 2b squared plus 6. Alright? Squared out, x squared twice the first by the second, squared last plus 6. So now that's your function of x, and that's your function of x plus h. Is that alright? So then if we put it into our formula, aren't it? So then your function of x plus h minus your function of x is equal to x squared plus 2xh plus h squared plus 6 minus x squared plus 6. Is that alright? Which breaks down to being x squared plus 2xh plus h squared plus 6 minus x squared minus 6. What happens then? X squared's knocked out. What else knocks out? Minus 6 and plus 6 go. So then you have 2xh plus h to be squared. Right. What's the next part of the formula? Yeah, exactly. So the next part of the formula is the function of x plus h minus the function of x all over h. So we divide all these by 2xh divided by h plus h squared divided by h. What happens? H cancels there, squared cancels with the h. So you're then left with 2x plus h. What's the last line in the formula then? Exactly. The function of x plus h minus the function of x over h is the limit as h approaches infinity, or 0 even. So that's 2x plus 0, and your final answer is 2x. So this comes up about 2 in every 3 or every 4 years. They love this differentiation from first principles. And it didn't come up last year to the best of my knowledge. How do I know my answer is right? Do it the quick way, exactly. If you differentiate x squared plus 6, it's simply just 2x. Right, with that in mind, have a go at this one for me. Differentiate, x squared plus 11x from first principles. Differentiate that from first principles. Differentiation done, Bernsley. Right, we have a quick little look at it. So, function of x is equal to x squared plus 11x. The function of x plus h is equal to x plus h to be squared plus 11 times x plus h. So that's x squared plus 2xh plus h squared plus 11x plus 11h. So then the function of x plus h minus the function of x is equal to x squared plus 2xh plus h squared plus 11x plus 11h minus x squared plus 11x. Obviously both of these are minus then, so that's minus x squared will cancel with plus x squared, and minus 11x will cancel with plus 11x. So you're left then with 2xh plus h squared plus 11h. The next line of our formula then is function of x plus h minus the function of x all over h. So divide each one of these by h, h, and h. They cancel, h cancels with the square, and h cancels with the h. Cancel, 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 cancel. So your last line then is 2x plus h plus 11, and that's the function of x plus h minus the function of x over h as h approaches 0, which is equal to 2x plus 0 plus 11, which is 2x plus 11. H goes to 0. And we know that's right because you go up and quick differentiate x squared plus 11x, you get it, right? We'll do one more of those and we'll move on to the next thing. Have a go at this one. X squared minus 2x plus 1. Right. So the function of x is equal to x squared minus 2x plus 1. Function of x plus h is equal to x plus h to be squared minus 2 times x plus h plus 1. So that's x squared plus 2xh plus h squared minus 2x minus 2h plus 1. The function of x plus h minus the function of x is x squared plus 2xh plus h squared minus 2x minus 2h plus 1 minus in a bracket x squared minus 2x plus 1. That obviously becomes a minus x squared, cancels with the plus x squared. That becomes a plus 2x, cancels with the minus 2x, and that becomes minus 1, and it cancels with your plus 1. That leaves you with 2xh plus h squared minus 2h. Function of x plus h minus the function of x all over h, divide by h, and h, knocks with knocks, knocks with knocks. 2x plus h minus 2. The limit as h approaches 0, 2x plus 0 minus 2 equals 2x minus 2. All good? Right. On to basic differentiation by rule. So I want you to differentiate the following for me. So just differentiate the regular a. Differentiate 1 over x squared for me. What you get in? So, first things first is you bring up the power, yeah? So that becomes up x to the power minus 2. So dy dx then is equal to, bring down the power, minus 2 times x, reduce the power by 1. Take 1 away from minus 2. Minus 3. Minus 2x to the power minus 3. Differentiate this for me. Minus 5x squared. What you get there? Dy dx is equal to, bring down the power, 2 times minus 5x, reduce the power by 1, minus 10x. Have a go at this one. Differentiate x plus 1 over x. Oh, it's very like this one over here. So that's the correct answer. A lot of people simply say minus 2 over x b cubed. So there's no, if they don't ask for it, then pick the formula. So dy dx then is differentiate x, you get 1 plus, this is x, this becomes x to the power minus 1. So that's minus times x to the power of minus 2, which is equal to 1 minus x to the power minus 2, or some people say 1 minus 1 over x to be squared. Either way it works. Have a go at this one. One minus x to be squared. What do you think? Minus 2x, exactly. Differentiate 1, you get 0. Differentiate minus x squared, bring down the power. Minus 2 times x, reduce power by 1, which is simply minus 2x. Right, have a go at this one. 1 over root x. What's the power for square root of anything? Power of a half stuff. You should have page 25 in the logbook open ahead in front of you as well as. So all these rules are. What do you reckon? Do you reckon fair? Sounds about right to me. Let's have a little look at it. So, y is equal to 1 over x to the power of a half, first of all. That is x to the power minus a half when you bring it up. Dy dx is bring down your power minus a half times x, reduce your power by 1 minus 3 over 2, which is equal to minus a half x to the power minus 3 over 2, which is equal to minus 1 over 2x to the power of 3 over 2, just to make it look a bit nicer. VI. This answer right here is completely acceptable as well. I'm just trying to make it look a bit nicer. X to the power of 4 minus 2 over x to be squared. So, y is equal to x to the power of 4 minus 2x to the power of minus 2. dy dx is equal to 4x to be cubed minus 2 times 2x to the power of minus 3, which is 4x to be cubed plus 4 times x to the power of minus 3, which is equal to 4x to be cubed plus 4 over x to be cubed. Yeah? Right. Bit of product rule. Example 5. That's the basics of differentiation. You don't get much tougher on the basics than that. So, differentiate the following. So differentiate the following, use the product rule. Product rule is the top one, yeah, in your logbook. 2x plus 3 by x minus 4. So we call the first one u and the second one v. So, u by v, bit of rough work out to the side. U is equal to 2x plus 3, du dv is equal to 2, v is equal to x minus 4, dv dx is equal to, sorry, that should be dx bottom. 1. So our formula is u dv dx plus v du dx. U is 2x plus 3 by dv dx, which is 1, plus v, which is x minus 4, by du dx, which is 2. 2x plus 3 plus 2x minus 8 is equal to 4x minus 5. You all happy with that? Write another one of those. Have a go at y is equal to x plus 5 times x squared minus 3x plus 2. So, 3x squared plus 4x minus 13. U by v again. So, u is equal to x plus 5. Du dx is equal to 1. V is equal to x squared minus 3x plus 2. dv dx is equal to 2x minus 3. So u dv dx, u is x plus 5, dv dx is 2x minus 3 plus v, which is 1, times du dx. Sorry, v is x squared minus 3x plus 2 by du dx, which is 1. So 2x squared minus 3x plus 10x minus 15 plus x squared minus 3x plus 2. 2x squared and x squared is 3x squared minus 3x is minus 6x plus 10x is plus 4x minus 13. Right, differentiate the following using the quotient rule. Q U y is equal to 2x minus 1 over x plus 3. What rule is the second one? The rule of thumb is, guys, you don't actually have to square out the bottom line. Just leave it as whatever it is to be squared. I think x plus 3 to be squared. Right, let's have a little look at what you get then. Let's look at it. So u over v. U is equal to 2x minus 1. Sorry, 2 seconds. Du dx is equal to 2. V is equal to x plus 3. dv dx is equal to 1. So your rule is dy dx is equal to v du dx minus u dv dx all over v to v squared. So that is equal to v, which is x plus 3, by du dx, which is 2, minus u, which is 2x minus 1, by dv dx, which is 1, all over v to be squared, which is x plus 3 to be squared. So that is 2 by x is 2x, 2 by 3 is 6, minus 1 by 2x is minus 2x, minus 1 by minus 1 is plus 1, all over x plus 3 to be squared, which is equal to 7 over x plus 3 to be squared. All happy with that? Right, have a go at this one. One minus x over 2x minus x to be squared. Right, let's have a little look at it. So, u over v. U is 1 minus x. V is 2x minus x to be squared. So, du dx is equal to 1 minus x, so it's minus 1. The v dx is equal to 2 minus 2x. Yeah? Then the y dx is equal to v du dx minus u dv dx all over v to be squared. So that's equal to v, which is 2x minus x squared. Du dx is multiplied by minus 1 minus u, which is 1 minus x by dv dx, which is 2 minus 2x all over 2x minus x squared to be squared, which is equal to 2x by minus 1 is minus 2x. Minus x squared by minus 1 is plus x squared. I'm going to do bracket and then multiply in the minus, the easiest way to do that. 2 by 1 is 2. 2 by minus x is minus 2x. Minus 2x by 1 is minus 2x. Minus 2x by minus x is plus 2x squared. That is minus 2x plus x squared. Minus by 2 is minus 2. Minus 2x minus 2x is minus 4x by minus is plus 4x minus 2x squared, which is equal to minus 2x squared plus x squared is minus 1x squared. 4x minus 2x is 2x minus 2. Did you get that? Oh, the stuff there. What did I go wrong on? See, you mixed up your formula, did you? Oh, alright. Did you get that? Good stuff. Right, last little rule of the three, chain rule. Now, the way they do it in the logbook is confusing as hell. Alright? For some reason they wrote it down like that. Bring down the power. Leave the bracket. Reduce the power by 1. Differentiate the bracket. So I got sure I've looked at that rule in the logbook about 4 or 5 times and I keep messing up every time I do it. That's the easiest way to differentiate by the chain rule. Bring down the power, leave the bracket, reduce the power by 1, differentiate the bracket. Do you do it different? If you do it different, do it whichever way you feel comfortable. That's the way I was talking now. And that's the way I teach my lads. If you do it slightly different, work away. You do that way? 12 times 3x plus 4 to the power 3. So as I said, you might do it slightly different in school. If you do it different in school with your teacher, fire away, do it that way. It's just the way I always found the easiest way to do. So, dy dx. I bring down the power, 4. I leave the bracket, 3x plus 4. I reduce the power by 1, I get 3. I differentiate the bracket, 3x plus 4, you differentiate, you get 3 like that. Tidy it up, 3 by 4 is 12 times 3x plus 4 to the power 3. The tidiest way to do that. I've got this one. Two x squared plus 1 to the power of 5. Bring down the power. Five, leave the bracket, 2x squared plus 1. Reduce the power by 1, you get 4. Differentiate the bracket. Differentiate 2x squared, you get 4x. Is equal to 4x by 5, which is 20x by 2x squared plus 1 to the power of 4. Right, I'll go with this one. Differentiate that for me. Hint is it's chain rule.
Yeah, it's a different way. Yeah, if you touch it, that's good. It's going to be a lot more difficult than that. These get a bit more complex. Yeah, it was just. Yeah, no, I've seen that done before. That's alright. It's just when you try to do it that way, when these get like e's, yeah, the power of x and the power of e's, it's a bit more difficult.
So, y is equal to 4x minus 3 to the power of a half. Dy dx is equal to, bring down your power, a half. Leave the bracket, 4x minus 3. Reduce the power by 1 minus a half. Differentiate the bracket, we get 4. Which is equal to 4 times 4x minus 3 to the power of minus a half all over 2. Yeah? That's 4 over 2 times 4x minus 3 to the power of a half. Make it real tidy looking. That's 4 over 2 times the square root of 4x minus 3. It's all about just making it as tidy as possible. Anyone confused in that I did there now? Because that's a bit complex. Ask me. Don't be afraid to ask me. Have a go at this one. Oh, I won't give something that random. Right, I'll go at this one. Y is equal to 1 over the square root of 2x to be squared minus 4x. Differentiate that. I mean, can you over v this if you want? I'm not going to do v. I'm not going to be over v it. I'm going to chain root it, which can you over v if you want. Different way of doing it. We should. You over v it, you chain root it. Right, so that's 2x squared minus 4x power of a half. Bring, that's in bracket. And then bring it up. No, so it's in a bracket and it's the power of a half. And then bring the power up to the top line. It's minus half and then chain root it. So then it's minus half times 2x squared minus 4x or minus 3 over 2. It's 4x minus 4. Right, yeah, I think everything on focus on that. So on your top line, you will have minus 1 for this, or that, and then the over 2. So like that, and then this. Then show you try keep negative power on the top line. If they don't ask you for it in a certain format, that's perfect, but they generally will ask you to put it in a certain format. Right, I think we're fairly all along the right lines. So, y is equal to 1 times 2x to be squared minus 4x to the power of minus a half, yeah? So obviously 1 by anything is just itself. So dy dx then. Bring down your power. Minus a half times 2x squared minus 4x. Leave the bracket. Reduce the power by 1. Differentiate your bracket. So that is equal to minus 1 times 4x minus 4 by 2x squared minus 4x to the power minus 3 over 2 all over 2. That is equal to minus 4x plus 4 over 2 times 2x squared minus 4 to the power of 3 over 2. That okay, guys? Right, let's step these up a bit again. Using the previous 3 rules, differentiate the following. What's the problem? So, you have this x squared times x plus 3 to the power 4, or if you have x squared plus x plus 3 to the power 4. This one is a lot harder than this. Is that alright? The reason for that is, for this one down here, all you have to do is differentiate x squared and then chain rule this, because they're set. The plus in the middle or the minus in the middle, whichever it is. This there, stuck together. So two things are stuck together, multiplied must be u by v. Alright, so you must be u by v. So the reason you're using two rules here is u by v, and then v is a chain rule difference.
Could you multiply it and then chain it?
No, base are the same. Because that is an x squared by x plus 3. That's x squared by x plus 3 by x plus 3 by x plus 3. 4 times. Don't really be allowed to multiply that in. Put that to the power 4. So if you chain rule it, 4 times x plus 3 is power 3 by 1.
Yeah. And what do you do then with x squared?
So it's a u, but this is your u.
Yeah.
That's your du dx. This is your v. And then the v is 4 by x plus 3 to the power 3. So then you just put it into your rule format. U to v dx plus v dx.
Right, let's have a little look at it. So, as I said, u by v. U is equal to x to be squared, du dx is equal to 2x. V is equal to x plus 3 to the power of 4. The v dx is 4 times x plus 3 to be cubed. By differentiate that, which is 1, so you just get the same thing. So then it's u dv dx. So u is x squared by dv dx, which is 4 times x plus 3 to be cubed, plus u dv dx plus v, which is x plus 3 to the power of 4 by du dx, which is 2x. So then that's 4x squared by x plus 3 to be cubed plus 2x times x plus 3 to the power of 4. Ever not happy with that? Any questions? Fire away if you do. Right, I'll go with this one. X by the square root of 1 plus x to be squared. Right, let's have a little look at it. So, u by v. U is equal to x. Du dx is 1. V is equal to 1 plus x squared to the power of a half dv dx is equal to a half times 1 plus x squared to the power minus a half. Differentiate x squared and you get 2x. So that is equal to 2x times x plus 1 plus x squared to the power minus a half over 2. Make it look a bit nicer. Cancel them. Is equal to x over 1 plus x to be squared to the power of a half, or x over the root of 1 plus x squared. Alright? Then, u by v, so it's u dv dx plus v du dx. So u is x by dv dx, which is x over the root of 1 plus x to be squared, plus v, which is the square root of 1 plus x to be squared, by du dx, which is 1, which is x squared over the square root of 1 plus x to be squared plus the square root of 1 plus x to be squared. You have to support a half, perfectly alright. As I said, if they don't ask for a format, that's grand. As in, like, you could have brought it in like that. There's nothing wrong with bringing it in like that. Right. Next bit. Nearly there, guys. 15 minutes. Example number 9. Differentiate. That's good work, lads. That's about 2 weeks of differentiation put into an hour there. Differentiate the following trig functions. So y is equal to the sine of 4x. So page 25 again, guys. Watch one there. Yes. Right, the rule with differentiating trigonometric functions is you differentiate the function and then you must differentiate the x if there's an x there. Is that alright? So, what I mean by that is dy dx. Differentiate the sine of 4x and you get the cos of 4x. But you also must differentiate 4x and you get 4. So that's equal to 4 times the cos of 4x. Right. Have a go at this one for me. I'm not going to go with that one. Y is equal to the cos squared of 2x. If you don't know your rules of trig, you could get slightly caught here. Right. Do we know another way this can be written? Cos squared of 2x. Cos of 2x to be squared. Alright, same thing. Cos squared of 2x is the cos of 2x to be squared. That's a rule of trig. Alright, have a go at differentiating it, so then. Right. So, dy dx. What am I going to do? Bring down the power, leave the bracket, reduce the power by 1, and then differentiate the cos of 2x then, I get minus the sine of 2x by 2. Is that alright? So that's equal to 4 times the cos of 2x by minus the sine of 2x. So I'll have a go at this one then. Triple I y is equal to the tan of 3x plus 2. 10 minutes, guys. We're nearly there. What do you reckon, Ev? Any ideas, Ev? Yeah. So, y is equal to tan of 3x plus 2. So dy dx is equal to, differentiate the trig, sec squared of 3x plus 2, then differentiate the bracket, you get 3, which is equal to 3 times sec squared of 3x plus 2. Have we got this one? Cos cubed of x. Off you go. Differentiate the cos cubed of x.
Well, Faye, what do we get?
Sounds right to me. Let's look at it. So, if y is equal to the cos cubed of x, that's also the cos of x to be cubed. So, dy dx then is equal to, bring down the power, 3 times the cos of x to be squared, differentiate cos, and you get minus the sine of x, differentiate x, and you just get 1. So that's 3 times the cos of x to be squared minus the sine of x. Right. Second last one of the day. Have a go at this. X squared by the cos of 2x. What's the problem? Well, yeah, you might. And then two variables solve after each other, so it's your u and it's your v. This that should be the last one today. Yeah, man.
You've got all your differentiators, right? It depends how you put it into the rule, though. Right now. Minus 2x squared times the sine of 2x minus 4 minus 2x.
I'm not 100% sure on that last time. Right, let's look at it. U by V. So, U is equal to x squared. Du dx is equal to 2x. V is equal to the cos of 2x. dv dx is equal to minus the sine of 2x times 2, which is equal to minus 2 times the sine of 2x. So, u dv dx. U is x squared. dv dx is minus 2 times the sine of 2x plus v is the cos of 2x times 2x du dx. So that's minus 2x squared times the sine of 2x plus 2x times the cos of 2x. All right? Right, boys and girls. See you next week, and then we'll have a week off.